Hi ladies, this is Blaufuss here. This is lesson 4.4, and it's about proving or showing that triangles are congruent using a few shortcuts. So we're going to look at a few different methods. We're going to redefine congruence, or we're going to define congruence again just to refresh your memory, and then look at a couple valid congruent shortcuts and a couple invalid ones. So if you remember from earlier this semester, we talked about congruent polygons, and two things had to be true for congruent polygons. So in this lesson, we're talking specifically about congruent triangles, but congruence for polygons is the same for every shape. So if a polygon is congruent to another polygon, that means that, so this is for congruent triangles, that corresponding angles and sides are congruent. So we're going to look at a few shortcuts, just looking at a few sides and a few angles to show that no matter what, if this is true, then the whole triangle will be congruent to the other triangle. So the first thing that you need is this key vocab term, which is included angle. So in your note sheet, you can see this included angle here. So this is the included angle between these two sides. So an included angle is the angle between two reference sides. Alright, so we have this shortcut, or this conjecture, which is side, 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 abbreviated as SSS, and that says that if three sides of one triangle are congruent to the three sides of the other triangle, so we've got three sides on one is congruent to all three sides on the other, then the two triangles are congruent. So this is a shortcut. So if you see a triangle and a triangle, and all three corresponding sides are congruent, then by this conjecture, those two triangles are always going to be congruent. The second conjecture that we have for this lesson is side angle side conjecture. So if two sides and the included angle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. Okay, so for this side angle side conjecture, which is the shortcut side angle side, we've got two sides in the included angle. So this would look like this. So we've got two sides. So this side would be congruent to this side. This side would be congruent to this side. And then the included angle, meaning the angle between those two sides, would be congruent. So if you have that, that means that those triangles are always going to be congruent by this congruent shortcut, side equals side. Okay, so let's look at these. 3 pairs of congruent sides. So we've got 3 sides. 1 side here, 2 sides, and 3 sides. So that's side, side, side. Are those 2 triangles congruent? Yes, we just looked at that one. And then the second one, 2 pairs of congruent sides. So here's 1 pair of congruent sides and another pair of congruent sides and the angle between those 2 sides. So that's our included angle. That's side, angle, side. And yes, that is always going to be true. Those 2 triangles will be congruent. And then the third one, 2 pairs of congruent angles and 1 pair of congruent sides between the pair of angles. So this deals with an included side. And we'll talk about this next lesson. So this is lesson 4.5. But yes, this will also be true. And so this is angle, side, angle. So if you have those, you have an angle congruent to an angle in another triangle, and then, or 2 pairs of angles that are congruent, and the side in between that pair of angles, then you can use the angle side angle conjecture, which is a shortcut to show that those triangles are congruent. All right, and then looking at the next page, so if you turn your note sheet over, we've got 3 more. So what about these next 3? So this first one, again, we're going to talk about this one in lesson 4.5. That's the next video. But if you have this, this is a side, an angle, and another angle, congruent to side, angle, and another angle, then yes, these triangles are congruent. So side, angle, angle is a shortcut. So that's a shortcut to prove that the 2 triangles are congruent. And then looking at this next one, and this one we're going to look at today. We'll get into it in a little bit, but this is side, side angle. So we'll take a look at that one in just a second. And then this last one is angle, angle, angle. All right, so let's look at the side, side angle conjecture, and let's determine whether or not it's congruent. So if we have a triangle, and actually I'm going to make this a little bit smaller. All right, so let's look at this triangle for a second, and we can label it A, B, and C. Okay, now we're looking at the side, side angle conjecture. And is this a congruent shortcut? So if we have this side-side angle, does that show that the triangles are congruent? All right, let's keep this angle. We're not going to change it. Let's keep this side. We won't change it. And we won't change that side. Actually, just to make it a little easier for me, let's keep this side. Okay, so side, side, angle. We have a side, and we have another side. All right, so when we were doing our construction, we used our compass a lot. So let's use our compass for a second and use that to duplicate this segment AB. So if I take my compass and I use it to draw a circle where B is the center, then AB is my radius. Now any point on that circle is going to be the same distance away from B. So I could have this line or this segment here that is the same as AB. So if I were to draw these triangles again, just so you can kind of see, I could have this triangle, B, A, C, that looks like this. And then I could have this other triangle, B, which 101. I could have this other triangle here. Let's do it at the bottom. That looks like this. B, A, C. And these sides are congruent. I know my bottom picture looks a little bit smaller, but you can see from the diagram that I drew up here. So this side is the same. This side is the same. And this angle is the same in both triangles, but these two triangles are clearly not congruent. So that's why this one does not work. So if you go back to your conjectures, side, side, angle, no, this is not a shortcut. And then this last one, again, we'll do this in the next lesson. But no, angle, angle, angle is also not a shortcut. All right, so this lesson covered those first two shortcuts, which was side, 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 and side, angle, side, and then one that was not a shortcut, which was side, side, angle. So this one, side, side, angle, does not work, but side, 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 or side, angle, side, those are valid shortcuts. So we can use those. So in this extra example, which again is on your note sheet, we want to find out which triangles are congruent, and then identify the congruence conjecture that explains why. Well, in this first diagram, and again, we can mark what we know, but anytime in a diagram you have a shared side, like side BE is in triangle ABE, and it's also in triangle CBE. So that's kind of a given that that side is congruent. So just looking here, we can say that triangle ABE is congruent to triangle CBE because of side, side, side. All right, so that's our first triangle, our congruent triangle. Another congruent triangle is we can look at these, let's say, I'm going to erase this one. We can look at this triangle, and let's look at this triangle. So there's not a whole lot of information given, but we do see that this is a shared side. Okay, Okay, so we can mark DE congruent to DE because it's a shared side. And then secondly, it's not given, but if this is a 90-degree angle, then this is 90 degrees, and this is 90 degrees, and this is 90 degrees. And we can get that using the linear pair conjecture or vertical angles conjecture to show that all four of those sides, all four of those angles are perpendicular. So now we have, let's do this one in blue. So now we have side AE is congruent to CE. So that's one side. Then we have angle AED is congruent to, to angle CED. And then lastly, we have side DE is congruent to side DE because it's a shared side. So that one is kind of a given. You have to think about it for a second, but it's kind of a given. So we have triangle AED is congruent to triangle CED because of side angle side. Okay, I'm just going to move these all down so that I can use this space. Okay, so those are two triangles that we showed were congruent. Now, let's look at another triangle. Let's look at ABD. And triangle CBD. All right, so for this one, again, we have a shared side here. And since we already proved that ABE is congruent to triangle CBE, we know that this angle has to be congruent to this angle. And secondly, since we already proved that triangle AED is congruent to triangle CED, we showed that this side is congruent to this side. So now with this last triangle, looking at triangle ABD and triangle, oops, I shouldn't make that marking yet. So triangle ABD and looking at triangle CBD, we can show that they're congruent using a couple different things. So these are congruent either because we have three congruent sides. So side, one pair of sides, two pairs of sides, and three pairs of sides. Or because we have a side, an angle, and a side. So side, pair of angle, and a shared side. So we can either use the side conjecture or the side angle side conjecture. Either one of those, either one of these two will work for our shortcut. All right, let's look at the next example. this says that if AC is congruent to DE, so let's mark those, and AB is congruent to DF, and angle C is congruent to angle E, we have side angle, so a corresponding side, and a corresponding angle, but the angle is not included. So it is not an included angle. This is not an included angle. And if you go back and look at your shortcuts, this one, side angle, is the one that we disproved as a shortcut, side angle, because we could have two congruent sides and a congruent angle, but if the angle is not included, then we end up with two different triangles, or we could end up with two different triangles. Oops. So since the angle is not included here, side angle is not a shortcut. So we cannot conclude that these triangles are congruent. It doesn't mean that they are not. It just means we don't know for sure that they are. So we cannot conclude triangle ABC is congruent to triangle DFE. Because side is not a shortcut. Alright, so that's it for this lesson. So please jot down any notes or questions that you have and bring them to class. Thanks.